Hello to anyone for being here. It's always a pleasure to know that there are a few different people on the other side of the. Before I start, I just want to thank you guys again for leaving such constructive criticism. I've gotten quite a few responses from my survey, and I just really want to convey my thanks for taking the time to fill out that survey, because it's because of your criticisms that I'm going to be able to make these tutorials much more informative and interesting for you guys. And so I encourage you, after this demonstration is done, to please go ahead and just fill out that short survey again, so then I moving and start applying your guys' suggestions. So this is going to be a short one today. Today we're going to be covering Ableton's Electric. And actually, Electric is an instrument that Ableton collaborated on with Applied Acoustic Systems, is the name of the company that put it together. For instrument is it's actually emulating the sound of an old, like, Wurlitzer or Fender Rhodes piano, in that it's actually instead of using like wavetable synthesis or being like a sample, it's generating the waveform with the computer's CPU on the fly. So I'm just gonna share my screen here so you can see. So if you guys are unfamiliar with what a Wurlitzer piano is or what a Fender Rhodes piano is, it's an instrument that was originally designed in the 70s, so it's got a really retro vibe. But what really makes it unique is the fact that it's not electronically generating the sound that it's producing. Instead, what it's doing is it's acting much like a piano does, but instead of a mallet hitting a string, it's in fact hitting a fork or a tine. So I don't know if you guys have ever seen those like melon instruments, where it's like a dried melon with a face plate or resonating plate glued onto it with a sound hole put into it, and then it's got these metal tines that are attached to it. And then you can like pluck the metal tines so that you can create your pitch, and then the length of the tine determines what the pitch frequency is. It's essentially like that, except for it's a little mallet that's hitting these little forks inside. And what Electric does is it allows you to adjust a lot of the different physical characteristics of the synthesized instrument, so that you can really have full control over the tonality of the sound that you're producing. So this is the Electric interface. Of course, you can bring the instrument into your track by just either double clicking on the instrument in the instrument section, or you can click and drag it onto any MIDI track, or you can click and drag it into this empty area here to create a new track and a new instrument on that track. So let's pull that up there. Okay, so right away you can tell that there are 5 different areas. One of these areas we are fairly familiar with because they're on every instrument that Ableton has. That's the global section, and we'll talk about that last. But starting from the left and moving to the right, we've got the mallet section first. So what this is going to allow us to do is adjust the parameters or the characteristics of that mallet that's actually hitting our digital tine. And by adjusting some of these characteristics, it's going to really make an impact on the harmonic content of our sound. So right now it's all in default position. So I'm just going to play a chord for you so you know how it sounds. Um, Sorry, maybe I should record on there. There you go. All right, so it sounds pretty good. It's got a really retro vibe to it. So if we want to adjust some of the parameters on the mallet, you'll really notice the difference in the tone. So just to give you a little bit of science behind sound and resonating materials, we know that the higher the frequency, the higher the pitch. So the harder the material, the higher the frequency. So if you've got a really, really hard material, it's going to be able to vibrate at a much faster rate. And if you have a much softer material, it's going to vibrate at a much slower rate. So thus either producing less higher frequencies in the harmonic content or producing fewer harmonics in the harmonic package. So if we want to increase the stiffness of this mallet, you're going to notice it becomes a lot more metal sounding. So if we were to throw, like, let's say a spectrum analyzer onto here, let's go audio effects, throw a spectrum analyzer there so we can see it. Now what I'm going to do is I'm going to just return that to default. I'm going to play a single note. So you can see that those harmonics there, there's the fundamental and the harmonics above it. Now, if I slowly increase the stiffness, you're going to see an increase of harmonics in the upper portion here of the spectrograph. Interesting, hey? So, of course, this is all emulated based on real math that's been taken from a mallet hitting a fork. And so instead of it creating like a really nice sort of ramp shape like a saw wave, it's mostly peaking at a few different frequency bands to really create that kind of hollow sort of metal sound. So if we were to reduce the stiffness here by turning it down past the 50% point, um, let's see how that sounds and looks. Okay, I'll just go like that. What was the... Okay, I think that's the note I was hitting. So I'm going to turn the stiffness down so it's a softer mallet. Now, not only has it become quieter, but you can tell there was that this second harmonic has been turned down quite a lot. Okay, so that's what the stiffness does. The force, of course, just changes how hard the hammer is hitting. So I wasn't changing the velocity that I'm hitting this note, actually. It's just changing the parameter inside of that section. Of course, we have controls here that you may recognize from other instruments where we can choose how much of an impact the velocity that we're hitting the note and the key that we're actually hitting is going to have on these parameters. So for velocity, if we turn this up to 100% and we hit the note very hard or even very soft, it's going to have a very high velocity. Well, actually, I'm doing this opposite. It's actually, if I have it negative 100%, it's going to be highly effective or highly sensitive to my velocity changes. And then if I turn it all the way up to 100, it's not going to have much of an impact on the pitch based on my velocity. So if you could see my finger, I'm like really hitting that note hard. So it's not really having much of a change on that parameter. So now key, we've seen this before in a few other instruments. And what this is it's also called key tracking. And what that will do is it will increase or decrease the parameter based on where in the piano roll we're playing. So if we're playing a higher note, it's going to turn the parameter up. And if we're hitting a lower note, it's going to turn the parameter down. So if you see this on pitch, like it's basically emulating how you tune an acoustic piano to make it sound more brilliant. What you do so that it sounds more brilliant is you tune the higher notes slightly sharp and you tune the lower notes slightly flat, and that just creates a way more brilliant sound overall on the piano. So this is allowing us to do that, but instead of affecting the pitch, it's affecting whatever parameters above it, so stiffness or force. So now we're talking about the actual transient. So what does it sound like when that mallet actually hits that tine? Because there's a little peak at the beginning of that note called the transient that we can make a very large impact on the sound based on how the pitch of that transient is and how the length of the transient is using these parameters here. So let's play around with that. I'm just going to adjust the pitch from the 50% mark. So I'm going to turn up the level so that it's a little bit more pronounced. You can hear it kind of sounds like knocking wood or something like that. If I turn this down, you're going to notice it starts to create a really kind of expensive vibe. Like, you know, when expensive things just are denser and heavier, that's basically what this is going to create the sound of. Well, in my mind, that's what it sounds like anyway. So that's what pitch is going to do. Decay is going to affect how long that initial transient is going to hold up. Sounds pretty bad. Ooh. All right. Okay, and then of course we have our control over key, just like these other parameters. Okay, so the second element in this instrument is the fork. So what is the mallet hitting? And of course, we can change the color of the fork. And I presume that the color of the fork is basically just like changing the metal of the fork or the hardness of the fork itself. Okay, I'm going to turn this up so that it's more pronounced. So you can hear a bit more brightness that's happening there as I turn the color up. And let's have a look at our spectrograph to confirm. So this is with the color turned all the way up, so we're seeing higher harmonics there. This is with it turned down. So it's very slight, but okay. So along with the color, we have the decay, so we can adjust how long those extra harmonics or reduced harmonics are going to be able to ring out. We can choose the level, the key, of course. We can choose the tone. Let's mess around with that a little bit. So, of course, how loud it's going to be, how long the decay period is going to be, and release. Fairly basic stuff. So here's a strange thing that is different with this instrument than any other instrument is the damper section. So in real life, when you hit a fork with a mallet, the fork is going to ring out and it's not going to stop until all of the energy from that strike has left the fork. So we want to be able to have some control over the note length. And the way that we do that is with a damper. So if you've ever opened up a piano and looked inside and pressed a key, you'll notice that there's a hammer and then there's this little kind of felt covered hammer as well that lifts off of the notes when you've got that note held down. And that's exactly what's happening here, but of course we're applying it to a fork. So some of the parameters that we can affect with the damper to change the sound of this instrument is the tone. So I would say that this is probably emulating what type of material is covering that damper. So do we have a damper that is like closer to a metal spoon at 100% and closer to like leather at 0%. So let's listen to that. I'm going to turn this up so then it's more pronounced. So you can hear that kind of metally sound as the note ends. So if I change the tone, it's like much quieter, softer. If I turn it all the way up, we've got that really metally sound. And then, of course, we can impact when this sound is being played. So at negative 100%, it's going to play directly on the attack of the note. And if we have it at 100%, then it's going to play directly as that note is released. Okay, so the very last section before the global section is where most of the magic happens. So this this section is indicating the pickup section of or amplifying section of the instrument, and this pickup is very similar to like a guitar pickup, where you'd have uh, you can either have an electrostatic or electromagnetic pickup or an electrostatic pickup. I think those are the terms that they're used, but those two types of pickups are what differentiate a Wurlitzer from a Fender Rhodes, because one is creating a magnetic field that is being interrupted by the vibration of the force, and the other one is just picking up the vibration directly from a static energy point, if that makes any sense. So then, because really what is making that mechanical kinetic energy into an electrical signal, um, uh, it really will make a huge difference on the overall sound of our instruments. So some of the options that we have here are symmetry, and that basically chooses if the pickup is directly under the fork or if it's kind of off to the side a little bit. So let's have a listen to how that sounds. I'll turn this down a bit. Right, so at 100%, we're getting a much lower tone. And then at 0%, I'm guessing we're probably to the clamp that's actually holding the tine. So if you move the pickup closer to the end that's moving the most, you're going to get more lower harmonics, which is just the same as if you're trying to mic up a guitar and you put the microphone right by the neck or over by the tuning pegs. You're going to get a lot more of that like high tinny sound than if you put it a little bit closer to the center of the string where it's moving the most. So another option we've got is the distance from the actual fork that we've got the pickup placed. So 0 being really, really close and 100 being far away. You'll notice that as we get closer to the fork, we're starting to hear a little bit of distortion that's happening, which could be what you're looking for, but that's basically what that is emulating. Of course, we can choose how loud the actual input is going into the pickup, which can also emulate a bit more of that distortion sound. All right. So let me just check what R and W is. I forgot. R position electric simulates. Okay, so here it is. R is simulating the or electric static model, so more like a Wurlitzer, I believe. Oh no, so R of course stands for Rhodes, and then W stands for Wurlitzer. So this is just choosing between the two types of pickups that you'll find in one of these real instruments that can also change the sound. Let's see how much it actually changes the sound. So this is the Fender Rhodes with the electric static or electrostatic Wurlitzer. it's a much softer sound with the electrostatic. I find the Wurlitzer seems a lot more like kind of in your face. Okay, and then of course we've got our key options here, which we talked about in the earlier areas. Finally, we've got our global section. So, just as a review of these, voices is indicating how many degrees of polyphony we can get before the instrument starts dropping notes. So right now it's set to 32, which means we can press 32 keys on our keyboard before it starts dropping notes. So if we tried to play a 33rd key on our keyboard, it would remove one of the notes. If we switched it to 1, that means it would be a mono instrument. We've got our detune settings, so we can adjust the tuning of the synthesizer based on semitones, or we can detune it based on cents. So in intervals of 50 cents in either to a maximum of 50 cents in either direction. Okay, so stretch, this is, basically the same thing as this key tracking, but it's actually being applied to pitch rather than just whatever parameter is above it. So, as I had mentioned before, if we've got this set to 100%, I believe the higher notes on the keyboard will be a slightly sharper pitch, and then the lower notes on your keyboard will be a slightly flatter pitch. There we go. Finally, the last parameter is pitch bend, and pitch bend is going to allow you to choose how many semitones you're going to be able to pitch bend your notes. So if I only wanted to be able to pitch bend it like one semitone, I could put it down to 1. And if I wanted to be able to pitch bend it all the way 12 semitones, so full octave, I can put it at 12. All right, there you go. That was a nice quick one. I hope you guys found it interesting. I personally never use this instrument. Um, I don't know why I don't. It's a pretty nice sounding instrument, but I guess I uh, really don't go for that retro vibe very often. However, I do suspect that this whole retro sort of 80s vibe is going to really come back in style in 2017. That's my prediction. So anyway, thank you guys again for tuning in. I hope this was useful. If you could leave me some of your views and opinions on my survey just underneath this video, I would really appreciate it. And and I will meet up with you again on Tuesday night at 7 o'clock. I don't know which instrument we're covering because I don't have my schedule up, but I promise it will be interesting. So anyway, I will catch you guys later. Thanks for tuning in.